This is the first class that will open the third module of the course, which is the make module, where we'll talk about characteristic of a production and manufacturing system which allows company to physically realize units and products that then are sold to the final market. These are the topics that we will address in this first class, in this first part. So first we will start with some basic concepts related to the production system. Then we will start dealing with the production system characteristics, adopting a managerial perspective. So we will see how production system can be classified according to a managerial view of this system, and then we will switch to a more technological perspective, and we will see the different production system typology according to the different technology that can be used to realize in practice this type of systems. Let's start with some basic concepts. First of all, a definition. Production system is put in place in a company in order to support the production process. The production process is one of the process of the company, and in particular is that process that realize the transformation of materials into products, so economic goods that can be sold to the final market, and which usually takes place in an industrial plant. So company has facilities, plants that they use to transform materials, components, and assemblies that they have in output to realize a final product. The importance of that is that this transformation occurs thanks to energy exchange that imply some changes in the chemical and physical feature of material. So it means that we have something in input that is transformed by the production system in something in output, and this output has chemical and physical characteristics which are different from what we have given in input to this type of process. In particular, this is a video that shows you an example of a production process. this channel package packaging and bring this way this wholesale retailer to then reach the final customer. This was an example of production process of a particular product, so a food product, chips, and as you can see, we start from raw materials, potatoes, and according to different phases, they are transformed from a chemical and a physical perspective into the final product. So, according to what we have seen, we can define the production system as the production process, so let's say the system where the production process is implemented together with all the management subsystems that lead to the achievement of the transformation. So the production system is that environment that include the realization of the activities of the production process, but also include also all the elements that are needed to realize this production process, meaning in input materials, so raw materials, components, subassembly, human labor, and tools to make the machineries function properly. As output the finished product, and then to make the production process functioning in a proper way, we need some, let's say, planning of production activities, we need a proper production organization, we need capitals because production process is made by machinery. Machinery are assets and assets are capital of organization. You need information system and you need commitment and managerial control. So all of this is what is in each company the meaning of production process. So it's not just the production system. So it's not just the place where production process activities are executed, but it's the place where production activities are executed, and all these elements are needed in order to make the process successfully executed. If it is clear, so this was just a general introduction, if it is clear, let's start into deep diving in some technical vocabulary related to production system and production process analysis, because this is important as we are dealing with technical stuff to be confident with some of basic nouns, some of basic definition which are related to production system and production process. First, this is evident, this is not production related. Let's start with the process. We talk about production process, meaning any part of the firm that receive inputs, in particular raw materials, components, subassembly, and converts it in output, so the finished products. That's the meaning of production process. Then we have a further definition, which is definition of a cycle time. A production process realizes product. The cycle time is the complete time that it takes to produce a single unit. So from the start of the production process to the realization of the final product, if you go and take the time that you need to realize that, this will be your cycle time. Then you have utilization rate. We will see that in each production system there are different resources, and utilization rate is a percentage. So it can be 50%, can be 60%, can be 70%, can be 100%, but it is the temporal rate that expresses the real use of a resource with respect to the time it is theoretically available to be used. If I say that a machinery has an utilization rate of 90%, it means that that machinery is available 100% of the time of the year, and of this potentially available 100% of time, I'm just using it, so it's actually active for 90% of that. So it means that I'm using an asset that I own in my production system only for 90% of the potential available time. So it will be available like 300 days per year. I'm just using 90% of these 300 days. It means that for the remaining part, the one of my asset is inactive. Then, when you are in a company, the production process is usually mapped or is usually visually represented. So this is some, let's say, graphical notation that you should be familiar with to deal when dealing with the production process. This is, let's say, the common way to represent a job or an operation. A job or an operation is a single activity, is, let's say, the highest, the lower level of analysis of the production process is one single activities that is relevant to be included in the representation of a production process. So a job or an operation is a single activity of the production process. Example can give, like, for example, give the entrance ticket to a customer, or install the engine on a car, or let's say refine the surface of a material, and so on. It's a single operation that is relevant to be represented from a visual perspective in your production process. Then this is instead a decision point. So this is the way the diamond square is a way to represent a decision point. When you represent a process, it will arrive a point in which you have to take decision. Like, for example, quality control. Is the quality okay? Yes. So you have one branch of the process. If no, you need to do further action. This is represented by this square, this diamond square, a decision point. For example, how much change to give to a customer, or what spanner to use, or which is the output of the quality control. It is a decision point. You have to take a decision, or you have to verify something in your production process. In particular, when you represent the flow, there will be a unique flow entering here, and then you have more branches exiting according to the type of decision or type of events that will affect the production process. Then you have, and we already seen that you have stock area or Q. This reverted triangle is represent a space for inventory. So it is something that includes product which can be which have been accumulated in the production process. So this is the way to let's say represent stock of product, or pay attention to the fact that even if I don't want to put warehouse or structure inventory in that point, this can be also a way to represent Q. Again, we have seen that different activities, different machinery in different phases can work at different rate. It happens that some Q can arise in front of the machinery or in front of a production phase. This is a way to represent that at this point of the process it is present a Q, or otherwise just that at the end of these phases or these activities is present let's say a buffer of inventory, a buffer of stock. The arrow, and this is easier, is a way to represent the flow of material. So through the arrow you represent how the process goes on between the different activities and the different phases. This is an example. I mean, we have a very simple production process which has just two phases, phase 1 and phase 2. And this means that, so it is a multi-phase process because we have two phases. And we are saying that the phase 1 produce for a buffer, so an area of stock between two phases where the output of one phase are put before being used in one of the downstream phases. So this phase 1 produce for a buffer phase, so for a warehouse, for example, or for an inventory space. And then phase 2 works by taking products from this buffer. Then here we have blocking. Blocking instead happens when activities of a phase must stop because there is no place where to put the just finished unit. So it means that when you have a blocking event, it means that um, the further activities need to stop because they have no more place to put the finished unit. So you are out of, there is a space constraint. So it means that you are not able to put any of the output of this product, of this process, in a specific phase, in a specific space in the production system. When there is no space available for the worker, of course, you have to wait that some space will be free, and until this won't happen, you will not be able to work the next unit. When instead blocking is when I am out of space. When instead starving happens when activities of a phase must stop because there is no work to do. So there is space and there are resources that can execute this type of activities, but they are not able to do that because they are not activities to be scheduled, or they are not in the condition to do work on that phase. Again, because anything is scheduled or because they have no more materials, the process is starving. So is waiting for input to know what to do, but actually the process is stuck. So there is no possibility to realize activities for some reason, and these of both of these two events, so blocking or starving, are of course undesired. So in the production system, you don't want to have neither blocking, neither starving, because it means that there are problems some way. In the first case, you have work too much, meaning that you have run out of space. In the second case, instead, you are not being able to plan activities or arrival of material, so that there is a moment in which some part of the production process are in the condition that they don't know what to do. Then other definitions that are useful to know, because they can be frequently used when dealing with the production system. The first one is bottleneck. We already talked about bottleneck when we introduce the concept of inventory management and how inventory management can be useful to decouple to subsequent phases, because one of the two can be bottleneck. Bottleneck is happen when the limited capacity of a process make pieces to accumulate or to be distributed not uniformly along the flow of a process. Again, different phases of the production system have different rate of working, have a different piece of working. If this rate of working, this rhythm that they keep in producing unit and in executing activities is very different, it means that pieces are consumed and accumulated along the process in a not homogeneous way. So in the long term, if you make a production system working, in the long term, in order not to create problems and disalignment from the different phases, all the phases will align to the same production rate of, let's say, the slowest one. The slowest one is called bottleneck. So is the capacity limitation of the slowest phase. So a bottleneck is a phase that works slower than the other one. And it's called bottleneck because, again, in the long run, if you don't put inventory or make some other type of initiative, in the long run, the production system will align its overall production rate to the one that is typical of the bottleneck. Pacing is no pace or pacing instead is the fixed time interval along the movement of item inside the process. Pacing means the time that encompasses between the processing by each phases of one unit to the following. So now is 10:30, and I am entering the first units to be worked in the production system at phase 1. Phase 1 finish working this unit at 10:45. It means that it can now receive a second unit. So it means that the pace if is 1 unit every 15 minutes. This is the pace of phase 1. Pacing means the rhythm that each phase in the production process can keep in processing unit. Then setup. Setup instead means that realize the concept of the fact that um, machinery can produce different type of units. Like for example, if you are Apple, you have to produce iPhone, you have to produce iPad, you have to produce iMac, you have to produce whatever. And there are companies that decide to share production system in order to realize different products. So the assembly line of Apple can realize iPhone, but can realize also iPad. Of course, the way in which machineries are configured to realize iPhone is not the same in which they are configured to realize iPad. In order to switch from configuration to realize iPad to configuration to realize iPhone and vice versa, you need to do what is called setup, saying the period required to prepare a device, a machine, a process, an equipment, a tool, whatever, to function and accept a further job. So, setup means that in order to realize a different unit from the current one, you need to reconfigure a device, a machine, a process, a system in a different way. The time you spent in reconfiguring this device, machine, or whatever is called setup. Setup time is the time that is needed to reconfigure an asset, a resource in the production system. Then, above this, there is one very important concept that you need to have clear when we deal with production system, the concept of lead time. We already talk about lead time when we have slightly talk about process management, because lead time is the time that is needed to perform all the activities of a generic process. So the lead time is the time in which the process starts and the time in which the process ends. If we focus this concept on the production process, we can define the lead time, so the production process lead time, as the time needed to perform all the activities from the customer order arrival to the moment in which the product is ready to be delivered. So please, this is important because when we refer to production process lead time, we are not just talking about the production process time, so the time needed to produce something. Production process lead time is the time that starts when the customer order arrives. So the customer is asking for the product, and so is asking to the production process to give him this product, and the moment in which he will have this product in his hands. Okay, so not in his hands, but the product will be ready to be delivered. So the production process is actually giving something to the distribution system to be distributed to the customer. Why I'm saying you that? Because in this time, not only the production process time is included, because let's see which are the components of the lead time of production. First, we have a phase, an administrative phase. When we receive a customer order, we first have to confirm the order to the customer by, for example, checking his credit, and then communicate to our production system that an order has been acquired and need to be released in the production system. So this is just a planning phase. I have acquired an order and I need to release it. I need to integrate this new order in the production system. Then, of course, the production system today is working. So it's not that an order arrives and you start immediately producing, you immediately start doing everything that is needed to produce that order. There can be process in place for other orders. So there can be queue at the machine to finish jobs that are actually in place, or there can be waiting times for materials because it's not said that you already have materials to realize that order. And this is another component of the lead time. Then you have what is called cycle time or production time, so the actual execution of production activities to realize the order. And you can see what is usually considered as the time of production is just a subcomponent of the overall production process lead time. After you have produced, which means doing setup of machinery, actually producing, so realizing activities, and it's not said that you just realize unit by unit. Wait for lot means that, and we will see that in the following, for your production system could make sense realize 100 units at time. So it means that before concluding production, you need to wait for the realization of 100 units because 100 units is an economic quantity that makes production efficient. So after having manufacturing the first one, you have to wait for 99 following units to conclude what is called the production lot. Then you check that everything is okay and production can be considered over. After that we are sure that production is okay, of course, we need to inspect and control the quality of what we have realized. So this is further time. As you can see that we are inbound and outbound of the production time, we have further time. So here we have administrative time and possible queue or wait for materials, and here we have inspection and final control. Then, once it's ready once the products are ready, it's not said that they are immediately sell to the customer. They can be stored somewhere waiting for the distribution system to be activated. So as you can see, the lead time, so a performance of the production system, meaning the time that production needs to make the product available to the customer, is not just composed by execution of activities. There are a lot of time components here that let's say contributes to increase the lead time and which are not really related to the action of producing. So they are other type of time, but that they are needed in order to realize in a proper way the final product.